This
So,
conference will now be recorded.
so just a quick, can you hear me okay?
Yes, we can still hear
You
you
can.
perfectly.
Okay, that's all right. I'm not sure what's happening with my screen here. So, yeah, I thought, so I'm here to present about the future proofing of our railway against climate change. I'm a little bit of a background for myself. So I'm, oh, come on, move. There we are. Right, so just a little bit of introduction about me. So I'm currently acting professional head of track. We've actually changed the title of that within Network Rail. It's Network Technical Head track. So that's the position I'm currently covering. Previously was engineering expert, but give you a bit of a background about myself. I joined the railway just over 25 years ago as a graduate engineer. Started off on the Bedford section with a certain Mr. O'Brien and a few others that probably may or may not be on this call, and carried on with as in a role as technical officer. Went over to San Diego to do S&C design, some of just as they were bringing in the new CNC machine, and then progressed then onto the Hitchin area as a track quality manager at on the East Coast. Following that, I moved over to the London Bridge area and then into Kent, into East Kent, track engineer, and then moved over to briefly to work for Balfour Beatty in a development role, and came back to Network Rail when just shortly after Network Rail was formed, and took on a delivery unit manager role in Anglia, a couple of locations in Anglia, both at Colchester and Tottenham. And then moved over to the West Coast main line at Euston as infrastructure engineer. Exciting time with the introduction of the high-speed railway, Virgin high-speed railway, which was a really exciting time. Some very interesting times over there as well. And then joined the centre as principal engineer before moving on to engineering expert. And as in my role as engineer expert for about three or so years, I then got into the climate change effect, and effectively was led the weather resilience infrastructure strategy on behalf of Network Rail's chief engineer. So that's kind of where I ended up getting so involved with our climate change, and hence my passion for that, and have a lot of interest in terms of trying to improve our network to be more agnostic to the weather. Okay, so I guess a bit of background to this. You know, we keep talking about climate emergency, and I know we've obviously got other priorities at the moment, but the climate emergency still persists, irrespective of what's happening with a certain coronavirus. And we can't bury our head in the sands because our infrastructure suffers from the effects of severe weather and extreme weather. And if we don't act, our planet will be in probably more dire straits, and I'm probably quite comfortable in saying this, that we'll be in more trouble than a virus has caused us, and that's something we do need to take account of. We've obviously got our other things worried about at the moment, but it's something that will certainly be an issue for us in terms of what the weather throws at us, and that will affect the whole planet. So currently, weather has an impact on a lot of our infrastructure. In recent years, we've seen the effect from trap buckles. Although trap buckles are actually reducing in number, we still suffer from trap buckles. We have a lot of effect from stormy weather, heavy rain, flooding parts of our embankments and causing disruption to services, eventually flooding our track. And we saw the effects, the really sad and horrific events in Scotland, in Carmont, more recently, and we know that weather can have a devastating effect on our network. But also in 2018, we had that long, dry, hot summer, which had an effect on drying our clay embankments, caused quite a bit of disruption to the network because of heat speeds. And invariably, all in all, we've had a number of incidents which have brought the railway to a grinding halt in some parts of the network. So, you know, the weather on our railways is a very stark reminder of the issues that we have to deal with, and we have to adapt to that. From a track perspective, the effects on from other events. So we saw in 2018, 2014, we saw the Dawlish seawall disappear in front of our eyes, and sort of the track luckily still stood there. Good old continuously welded rail track still hang there. But if we look back at 2007 in Dawlish, yeah, it was getting battered, and it's still getting battered today, but continues to hold there. We've improved the resilience and of the seawall, but the expectation in terms of our predicted sea level rises, and it is going up. By 2050, we're expecting to see around 36 centimeters of sea level rising. So despite what we've done at Dawlish, is only a short-term measure, and there's work being undertaken on by the local authority and also Network Rail, looking at diversions and ways of increasing that resilience to deal with the sea level rises that we're expecting to see by 2050, and in 2070 that may double. So there may not be very much there if the railway stays where it is. We've also seen the effects of flooding on some parts of the network in places like Wales and in the northwest, where we've seen areas of our network completely flooded from either local sort of estuarial or even lowland, where the rivers have burst their banks, and it's engulfed the railway and effectively brought it to a halt. And those sorts of events take months to repair, weeks, certainly months to repair and get the railway back up and running. So it's really important that we get an improved understanding of this systemic weather impacts on our infrastructure, and are better able to deal with those. The cost of weather-related failures as well. So whenever we talk about cost, I always, on the network, we tend to talk about Schedule 8, which is the cost of delays itself for disrupting the network. There's obviously a Schedule 4 element, so cancellations and just disruptions to not running the services, which in itself is also quite a costly event. But if we just look at Schedule 8, we can see that there is a rising cost from going back as far back as 2006. There is a rising cost from weather. Certainly in the last 10 years, we can see that the impact of weather is beginning to increase the cost to the railway in terms of disruption it's causing. If you compare that to 2006, where we had a really hot period, that was about 2.2 million in delays. But in 2003, where we had 137 buckles and a lot of speed restrictions, and we kind of suggest some of those speed restrictions, which were post Hatfield, may have been potentially as a consequence of that. But there was a lot of disruption due to purely due to track buckles and speed restrictions as a result of those. But even that doesn't compare with what we suffered in 2018, and that's the issue we're trying to deal with. And it's not just hot weather. We also see the effects of cold weather, of flooding, and cold weather is reducing. We know that that's beginning to reduce. The frequency of those events are going to reduce, but we'll still get cold weather. But flooding is becoming a big feature, and it's one of those aspects which we've got to control, we've got to manage better. Then if we look at some of our track assets, so a lot of our track assets actually broadly are pretty resilient. So most of our network actually functions correctly, and it's resilient to the current hot weather that we face. But we've got some vulnerable assets that you can see on the left. Jointed track is still probably about 40 to 50% of all our track buckles every year are caused by jointed track, either because we've over tightened some of the joints on the fish blades, or we don't have enough ballast, or there's a combination of other factors like geometry. If we look at some of our tight curves and S&C timber, especially timber S&C layouts, which are much more vulnerable to heat, purely because they're not as strong, not as robust. So they are, and we've also got an issue with some of our older variants of concrete sleeper track, CWR track, particularly those from the sort of 1970s, 1960s vintage, and there's still quite a bit of that around the network. So it's not, we're not certainly we don't have a rosy picture to paint. There's still areas of our network, even some of our key areas, some of our main lines have still got some of this sort of infrastructure either beside it or on it. And then we look at our predictions. So over the course of the last probably 12 years, NetRel has been working closely with the UK climate projections emission scenario. So most current one is the UK CP18, and there's there's about 12 scenarios within the projections that have been developed by various climate scientists and Met Office experts around, and also experts around the world. And one of the things we have come up with in terms of NetRels, we've actually developed a number of scenarios. We've picked up two scenarios. One is a sort of a medium emission scenario, and one is a primary sort of high level emission scenario. And we've settled on the medium one as a projection of what we might see in the next 30 to sort of 50 years. And these sort of illustrate what we might get. So looking at some parts of Scotland, broadly we'll be getting temperatures that we probably see in the southeast today. But as you come towards the south, certainly the Midlands and towards the south, temperatures start being what you might expect to see today in places like Spain and maybe south of France. And as we move on to 2070, that goes even higher, and Scotland actually starts getting hotter as well, getting to a point where our CWR track is reasonably resilient. So if we look at the table on the right hand side, if we're talking about good condition CWR, if you look at the more modern variants, it's probably slightly higher than that as well, probably a couple of degrees higher than that. But essentially, for normal track, predominantly it's quite equivalent to sort of 40 degrees Celsius. So up to about 2050, a lot of our network should function if it's maintained and managed, and to the level of resilience that it's designed to operate. So things like deficiencies of low ballast, sites that are not stressed, all those deficiencies that we've got, sites which have got wet beds in there, we've got lots of voiding, all those things just undermine the strength of the current asset, the track asset. But as we move towards 2070, some of those assets become compromised because we start getting towards the 44, 45 degrees Celsius. And at that point, there is a risk of potential speed restrictions of 30/60 in some places. And it's something that, from what I spoke about in terms of delays, that becomes an intolerable evil, essentially. And we need to look at ways of minimizing that impact. And that's certainly one of the things we've got to consider. It seems a long way away, but actually, if you look at how long it's taken us to, and it will take us to adapt and strengthen our railway, we need to act pretty soon, and we need to start acting now. And some of that is already beginning to happen. So just sort of qualify some of the points I was making. So we see that temperature rises, and when we get to, it's quite interesting, when we get around the sort of 20-degree mark, I call the sort of Goldilocks temperature in the UK, our infrastructure across the board generally tends to perform quite happily, and it seems to be quite comfortable in that space. But the minute we get over 25, 26 degrees, that the number of delay minutes and the number of incidents start to increase. And if you project that over 40, 45 degrees Celsius, we start seeing a much higher incident rate, which goes to a point much higher than what we see today. And it's something that we've got to really understand. This is the impact we'll be looking at, and it will affect the reputation of a railway because there'll be lots of speed restrictions, and the sort of Daily Mail test as such will be something that we'll be exposed to. when the railway comes to grinding halt because it's very hot. Of course, we can't forget the impact of other weather events. So, we know climate change is in the past, but actually the climate change affects our weather. So we know that from our projections that we'll see less incidents of cold weather. It'll be less frequent, but it'll still be cold, and we'll still get very cold spells like we did in. For those that remember the Beast from the East, a very cold, sharp spell in March a few years ago. So those events will still happen, but they'll be less frequent. The likelihood of earthquake failures from sort of shrink swell effect through droughts and also convective rainfall. We've seen some of the effects of those more recently. That will become more prevalent. Major floods, coastal storms, we're seeing more of that, but also inland storms will become more of an issue. And we'll start seeing potentially that will be 5 times more frequent by 2017, about 50 years time. But wind speeds, lightning, humidity, they all have an impact in, some of our overhead line, our trees disrupting the railway. Humidity having an impact on some of our equipment, electronic equipment particularly. And I mentioned about the sea level rise and some of our severe coastal erosions. Some parts of our network, if you look at parts of the southeast, probably around Dover, and some parts of the southwest as well, we may see sea level rise, which will engulf parts of those railways, and they will disappear because the sea will swallow them up essentially. So it's something that we need to adapt to prepare ourselves for how we're going to adapt our railway to deal with those extremes. And unlike extreme weather, we know climate change sometimes goes unnoticed for decades. But we also know that the effect on our infrastructure will be quite profound if we don't adapt and don't change to it. We're coming under a lot of increasing pressure from government, the rail industry, also the travelling public. Although if you travel on the train today, you may not notice very much because it's quite empty on trains these days. But I don't think we should be under any illusion that that will not ramp up eventually, and we'll be, have a very demanding public on our network again. So we've got to learn how to cope with the changing climate, and certainly a more recent publication by the National Infrastructure Commission in early this year to the UK government identified six particular aspects of resilience that infrastructure maintainers, infrastructure owners need to adopt. So those 6 things are anticipate. So actually anticipate the effect of climate change and weather resilience. Resist, absorb. So there may be certain things that we can do to strengthen our assets to actually absorb the effect of it, so it becomes more agnostic to weather. Also be able to recover. So in some extremities, in some really extreme events, which there's not very much. So lightning is probably a fantastic example. There's not very much you can do with where lightning's going to hit, but your ability to respond to it is definitely something we can control. And the quicker we respond, the faster we get the network back up and running. And then being able to adapt, and that's where the cost of resilience may come in, and that we just strengthen many of our assets. And then above, overline all those is transformation, is transforming that, so we move forward. So that's something that the government is demanding of us, to provide a railway that's safe, more resilient to the effects of weather now and also in the future. The graphs on the right give a bit of an illustration of where we currently are. So based on our current policy, and our policies are focused on track categories 1 to 3 predominantly in terms of renewal, and on those lower categories there's more of an ethos of refurbishment, but in some instances actually the cost of refurbishment and constant maintenance demands some renewal. So in some aspects we do that. But if we look at where we are with plain line, the blue line is sort of the more the more modern variant of plane line track, so CWR track G44, EG47 type construction with SEN 60. And the projections we've got based on our policies and the modelling that we've done within NetWell is looking at up to about 2050, about 62% or so of the infrastructure will be designed, installed to the modern standard, and that will cover most of our track category 1 to 3, which will basically be more resilient to the weather. So that the table I showed before, where we're talking about 60 or so 62 degrees temperature in terms of rail temperature, we're talking about around 42 to 44 degrees temperature in terms of the resilience before you even put a watchman out. So a lot of our infrastructure actually by 2050 will be quite sound. S&C is slightly different picture. So whilst we are, where we are in terms of the more modern sort of UIC 60, NR60 and NR60 Mark II, which is just the new version of our UIC 60 solution. We'll see more of that coming on stream, and over the course of the next 30 years, we actually seen probably only about a third of our infrastructure which is modern. That covers all our main lines. So the most important parts of our network, the most congested and the busiest part of the network certainly will be affected. But those are the bits that we're going to already do work, and we're planning to do a lot of work on. And also some of the secondary connections to those main lines will be the more designed to the more modern variant. But it does leave us with some assets which won't be, and we need to strengthen those to be able to cope with it. So we really have enhanced and improved our targeting of summer preparation, seasonal prep activities that we do. Lots of good practice shared around. Some good examples this summer of where some routes have done some excellent work to bring some resilience and robustness into the infrastructure. And of course, the development of our decision support tools, intelligent infrastructure, trying to use predict and prevent technology and algorithms to detect where we may get a problem, so we can actually build some resilience into those assets. So there's quite a bit of work in that space, but there's still clearly some more work to do if we're going to get to a position where we're able to cope with the effects of climate change. We've also got within NetWell, we've got a climate change policy, and the key thing about climate change policies, we know what climate change is going to do in terms of amplifying the risk, but the target really, rather than replace like for like as we've done and we've been doing for many years, it's actually replacing like for better, and that's really it's almost like the strap line is to replace like for better, and in that way we're looking at all the assets across the various disciplines, and there are obviously overlaps and interdependencies on some of it. So track very dependent on earthworks and also drainage and line side. So there's quite a lot of work in terms of where do we invest and how do we plan our investment strategies to identify where to put our money. And our plans really is to try and drive and anticipate what the weather looks like in certain regions within our network, develop ways to resist those, and find ways to absorb those risks, and then implement robust recovery plans, and effectively adapt against the threat of adverse and extreme weather. And one of the ways we are starting to do that is looking at vulnerability hotspots, sort of GIS, geospatial maps, and some of that is really available. We've been doing some work on the Earthworks, providing some geospatial mapping to sort of 5 kilometer square grids, probably trying to get down to 1 kilometer square grids, because some of the assets are that unique and very isolated to a very, very small section that you probably have to look at it in an even smaller grid square. And what we're doing with those is looking at, we're building some vulnerability risk assessments. We've already started that process for each of the asset disciplines, and using that knowledge, determining the economic impact. So earlier we talk a lot about Schedule 8 and Schedule 4, which is very railway specific. But if we look at the events of Dawlish a few years ago, about 6 years ago, the estimated impact on tourism on the southwest of the countries of Cornwall and Devon it ranged from anywhere around 250 million to there were estimates of very close to £1 billion in lost revenue from effectively people not being able to travel on the trains down, let alone just paying getting a train ticket, but even just getting down to that part of the network. And that was trade and tourism. So, you know, when we talk about business cases, a lot of our business cases are defined around Schedule 8. Actually, there's a far wider economic impact on UK PLC, and it's something we need to really take account of. So we're developing our capability to understand the true cost of weather resilience and also climate change. So the assessment will feed the analysis we're doing will feed into a vulnerability tool which we're developing, and the part of that is to give routes better tools to make better decisions. And that will enable routes and regions to be able to design which parts of the infrastructure they need to strengthen. And if you look at the map on the right hand side, just gives an illustration of the number of incidents and the delay minutes. But if you combine that with the economic impact, you would see much bigger bubbles and areas of real focus to try and drive down where we need to put our money in terms of resilience to climate change. And also adaptation pathways. So flooding is a key thing, and it significantly affects track. We've got examples in Wales at Cowley Bridge, which is notorious for flooding every year. And they've put in some measures to try and locally and look at the national, the economic and the locally economic factors which affect the particular area in Wales. And quite a bit of effort has been done to try and strengthen those and build those up. And whilst when you look at Wales, the example on Wales, you look at the example at Cowley Bridge, it's more of a medium-term solution. So it's definitely not going to be the permanent feature, and there's work to do to try and build further robustness into that. But as a start, what it does, it helps to manage the situations we've got today, and then further adaptation to improve the resilience with further weather and find ways of managing that. And that's not just a Network Rail, it's not just a Network Rail project. This is something that expands across the Environment Agency in Wales, but also local authorities, so that the whole region is, we're looking at the whole region in its entirety. And that's the sort of thing, that sort of collaboration really helps us to manage that, because some of those effects are not, the river in those areas is what's causing the problem, and no amount of drainage is going to make those robust, that area robust. So we need to think about a different way of doing managing the water in there. And then looking ahead, so some of the things we're doing around research and development, we've started looking at research and development to lateral resistance models, and that's looking at input. So we know already that when we look at stress modeling, geometry, the type of track, dynamic loading, sort of variation of different lateral resistance and track uplift, passenger and freight vehicle axle weights, ballast and subgrade, as well as track bed stiffness, and other environmental factors, all combined to have an effect on how resilient and how resistant the track is to lateral disturbance. And that's something we're developing. We're developing with universities, and as I mentioned, we're looking at vulnerability maps and bringing that into the equation. And the purpose of this is to develop in those models. We can start effectively almost playing tunes to the way in which if we get a certain type of weather, we can predict a certain type of weather as part of our development activities and our renewals activity. We can start looking at what using vast amounts of data, we can start looking at what sort of weather we may get and how the infrastructure may behave, so we can design it to cope with that far better than we do now. So application of wider systems thinking is a fundamental part of that, rather than funding for just track or funding for just earthworks. We combine what we actually do with both, so that we get the most robust whole life cost solution. further research into stress-free temperature range, and it's something we're challenged almost every year. I think I get the question each year from someone in the board. We need to increase the stress-free temperature range in the UK. And there's some possibly good arguments against it, but we also need to consider what the impact will be of doing that. So we have a very temperate climate in the UK compared to other parts of Europe, and therefore we end up with quite a range of temperatures. So by increasing the temperature of SFT, there is a risk that in the really cold weather, when we do get them, it might be less frequent, but when we do get them, there's a risk of having more rail breaks and the rail actually snapping. So we've got to balance that, and that's essentially the research that was done, in the sort of late 60s, early 70s, brought that into considered all those factors. There's an argument about maybe regionalizing SFT. So if you look at the temperature map I showed earlier of what the temperatures look like in the southeast compared to Scotland and northeast and northwest, potentially there is an argument that we should stress at a higher temperature, mainly because of it's essentially the sort of effect we get from the rolling out effect that we get whenever we install track, and that's something we recognize is certainly a feature in our infrastructure. So we've got we install our infrastructure, but we know we have a 2 to 3 degree loss reduction in SFT following installation. And one of the things we need to do is actually potentially we can do to combat that, to make the track more resilient, to potentially increase the stress-free temperature to something like 29 or 30. But that's a piece of work that we're going to do rather than kind of just do it and then see what happens. We need to do that piece of work to understand what the balance of risk is. I mentioned about predict and prevent decision supports tools already, and then improve and adapt in our construction and maintenance practice. And that's absolutely key. I think the way in which we undertake our construction and maintenance practice, we need to improve that. We need to change that, purely in the fact that purely just focusing on SFT is not necessarily going to give us the right answer. We need to also improve the geometry, and for me, I think the next stage is really looking at the tolerances we've got in our standards for track geometry and for track bed stability and track bed the track bed integrity as well. So one of the things we need to really do is actually improve our track quality. Where we've got discrete faults, is try and iron those out. So wet beds we shouldn't have wet beds. We need to get rid of wet beds and manage those better. So drainage maintenance is absolutely key to that. But we need to get to a point where we intervene so much earlier, so we're not tolerating those risks, because all of those, irrespective of SFT being at higher, will still contribute to a reduction in the critical rail temperature, and effectively could reduce and cause buckles, or enable us or force us to to put in speed restrictions. So just the last couple of slides. So in essence, we've got a strategy for climate change. We know what our challenge is to try and manage those risks. And one of the things we're doing to take those on board is we've got a strategic action plan in terms of investment, and that's looking at the whole industry. So we're talking to government, because we need government engagement. Essentially, if we want to make the infrastructure more resilient, we've got to work closely with government, because we may go to them with a slightly bigger bill in order to make the infrastructure more resilient. But we've also got to give government options. We can't just go with a big whopping check, request for a massive check to do the work, because I think certainly the last year has taught us affordability is going to be a big issue for us going forward. So we've really got to take stock of the economic factors that we're currently living in, but also challenge ourselves and work closely with our suppliers, and look at more innovative ways to adapt and to improve the network. We're already looking at apart from just making the infrastructure more resilient to climate change, we've got to look at also at the effect of our sustainability, and we've got an environmental sustainability strategy to achieve that sort of net carbon zero by 2050. It's a big part of that. So the installation of old wooden timbers that we used to do, softwood sleepers, that's going next year. We're going to be using more composite materials, recycled materials, trying to remove carbon from a lot of things that we do. And it's got to be the direction of travel. That's the way in which we need to work on the railway. The railway is still a fundamental part of the government's target of net carbon zero by 2050, because it's very green already, and it can still be a lot greener. So to conclude, as I mentioned, climate change is happening. Despite the recent events of the coronavirus and the impact it's causing on UK's finances, we have to continue to adapt, and we have to work towards adaptation. The extreme high temperatures that will increase the incidence of failures. We know we'll get more track buckles. The rise in train delays from applying speed restrictions is something that we can't tolerate. And the only way we can do it is cross-industry collaboration with external agencies. We've already started some work with UIC, looking at a more effective way of managing extreme weather events, and what as a European community can we do to manage our infrastructure better. And there's some examples across Europe of how to do that. So there's a lot of collaboration in that front. There's work that the ISO Guide 84 has produced in terms of guidance for writing standards, and standards something we need to take on board to sort of adapt our standards to consider the effect of climate change and what we'll do with managing the weather. And yeah, I mean, the last statement there, our ability to make the intelligent decisions, thanks to lots of data. We've got loads and loads of data, but we need to build the right technology to help us make the right decisions, to allow us to adapt, a lot of our Victorian railway to the green, sustainable transport option of the future, just so we can cope with the challenges that are presented by climate change. Okay, and that's it from me. Thank you. Right, are there any questions at all?
Put my webcam back on.
Thanks very much, Liam.
Yeah, thank you very much, Robert. So there must be some questions. I think we've got one in the comments. I don't know if you can see that, Robert, but shall I read it out? From Stuart Corrie.
Oh yes, yes, I can see that.
It says a derailment occurred near Mitre Bridge Junction, partly due to lack of ballast due to 2+ years delay on the ballast drop. How do we stop things slipping through the net when things like this become much more critical?
Yes. So yes, thanks very much for that, Stuart. So it's certainly a good challenge. So one of the things that I'm very keen on is we've got plain line pattern recognition train that runs across the network, all parts of the network, on the daily, weekly basis. And already we're getting some intelligence from that, so we can tell if there's too much ballast on the sleepers. So swap that around, you can tell if there's too little ballast, and the technology is there to do that. At the moment, it takes a lot of human intervention to actually review and manually review the information and review what actions you need to take. So one of the discussions we've already started with our intelligent infrastructure team, and also the PLPR measurement team, is how can we automate that so that it tells us, rather than boots on ballast and go and find out what it looks like and then arbitrarily make a note to say there's insufficient ballast. If we can measure it, we've got a better way of managing what we do with it, to that information. So that's really the challenge for us, is for us to actually be using technology to detect these deficiencies and then manage them more effectively. I hope that answers your question, Stuart.
We have a second written question. This one is from Alistair Kennedy. He says he's always understood that the temperature range in Central Europe is higher than the temperature climate we have here in the UK. So is there anything we can learn from how the railways in Central Europe manage this?
Yes, so it's certainly that I mentioned, that's one of the things we are doing with the UIC, is really trying to understand what other countries do in Europe as well. So in some parts of Europe, there are, a bit like the US, where they have slightly different stress-free temperatures. There are things that they do to try and manage that. Europe and some parts of France and Germany have a slightly different approach. So their sleepers are slightly wider, but also more curved on the end, and they don't necessarily heap as much ballast as we do. So they have different ways of managing it. The other thing that they do slightly differently in certainly Germany and France is they've got different techniques for maintaining their network and their infrastructure. So, I suppose something we used to do in the past, and I remember as track quality manager, one of the things that we always used to do is tamp and have your regulator behind you almost immediately. We've got some of the technology now in some of these machines which can do a bit of both. So we need to take advantage of technology to, certainly one of our challenges is access is always going to be diminishing returns in terms of some of our access. But I think what we can do is, yes, we can learn from Europe in terms of the temperatures that they have and sort of the higher temperature ranges that they deal with. But one thing we do struggle with the UK is because of our temperate climate, we do still have to manage the sort of diversity in ranges of temperature. So although some of the countries in Central Europe suffer from that, the way in which some of those sort of the lower parts of the parts of their network actually do struggle with that as well. So they're, speaking with some of our European partners earlier this year, it's one of the things they've been looking to us and saying, what do you guys do? Because we've been having last summer they had an absolute nightmare in some parts of France and Spain because the temperatures were so high. They were in the mid 40s and they had quite a few buckles because of it. We're not in that space yet, but it's coming to us soon. So there's a lot we can certainly learn from Europe, and part of the work we're doing as part of our European research work, and we've got people like Phil Winship and some of the team in Milton Keynes working very closely with European partners to look at things we can learn from them and some of the benchmarking which we can take stock of to improve how we manage that in our railway.
Okay, thank you. The next question is from Brian Counter. He might be able to unmute himself and ask it in person.
Hi, Brian.
Hello, I was going to show you a picture of me, but I've been taken away from the ability. There you are. You can see me. Just thought I'd ask you the question first. How are you? Thank you very, Robert. An excellent presentation. Really enjoyed it, and I'm quite keen on this area. I just wanted to ask you a question about standards because I know that we've sort of had a couple of years of temperate summers. When I go back to 2018 and we all started to panic a bit, if you remember, it was getting. We saw this standard that says if the temperatures, the air temperature is predicted to rise above 26 degrees in the next 3 days, you can't do anything that will involve any disturbance to the track. And that was my understanding of the standard. Is that still there, and does that still apply? Because that means you can't tamp if there's ever a week of any hot weather.
Yeah, so where the temperature reaches, I think it's 32. Once it's over 32, we and that's just the rail temperature. But for the air temperature, essentially if we're getting to around the over 25 degrees, 26 degrees, yes, it's something that we do stop doing work. And it is quite an issue because I think 2018 was a good example of that, where we because of the extent and the length of the summer we stopped doing tamping for probably about 6 to 8 weeks, in some places even more. And the resultant effect from that is we saw in the sort of late summer, early autumn, track quality just went the wrong way. And we ended up with a lot of speed restrictions. I can't remember the count of it, but it was over 400 speed restrictions across the network, which was getting towards Hatfield, sort of halfway towards the Hatfield days. So quite significant in that sense. And yes, that's certainly an issue with that. Now, it doesn't mean we can't do the work. I think the issue is if we do the work, then it's a balance between disturbing the infrastructure and the track, and essentially putting a speed restriction on. So it's trying to manage that and mitigate it. Now, in some instances, we've actually we had to do work. So where we have reports of twist faults, which are intervention levels, we certainly do the work, but we do it on a risk-based matrix, and it's how we've kind of managed the infrastructure as it is. The work we're doing with as part of our R&D is looking at what level of disturbance can we actually tolerate, because I think that there's always been this challenge, and certainly in my mind, some of the challenges we've had, and some of my experience working on the East Coast at Hitchin, about just how much disturbance can we tolerate, and I think that, you know, I suspect, and I might be wrong, there might be some conservatism in some of the way in which our standards, you know, manage the risk, especially when you look at the more modern track that we've got out there. So essentially what we're trying to do is to learn from some of that and understand that, but that's some of the modeling we're doing, and we'll probably do some trials as well, will help us to define that a bit better, and then we can go back to our standards and reflect it in what we're doing there. But you know, it's not something we can just say, let's just do it and see what happens. You know, I don't think our passengers will thank us very much for that.
Thank you very much.
You're welcome.
I think the next question is from Chris Parker. If he'd like to mute himself.
Hi, Robert.
Hi,
Thanks for an
Chris.
Interesting presentation.
You're welcome.
You referred to our Victorian infrastructure.
Mm-hmm.
I think the worst part of it, to me, is still very Victorian in most places, is the earthworks, cuttings, drainage, embankments, and all that stuff. Excuse me. They really have not been modernised in most places. And not only do they cause us some very, very expensive and disruptive failures directly, but excuse me, excuse me.
That's all right, Chris. You're okay.
They also cause indirect problems, causing poor top, other geometry defects, broken rails, all this stuff, and bring about a very large increase in the maintenance burden for track as well. So we really need to do something serious about them, in my view. What do you think?
Yeah, so I've always been quite interested in the effect of earthworks. So if we look at the parts of the southeastern Anglia, we get and Wessex, we get a lot of because of the clay embankments and the shrinkage we get there. We as they dry up, we end up in a scenario, and I think I recall a couple of years ago, one of the asset managers on Anglia, who took the train Southend every year, some of you know him, recalls starting his journey on Monday, and by the end of the week, the asset had deteriorated so fast that he had to put a speed restriction on, because that's how fast it degraded. So it's certainly a massive challenge for us. You know, we've got thousands of earthworks across the network, and they were all built 150 years ago, so a lot of them. And you know, unfortunately, our Victorian cousins and relatives threw loads of things into the embankments, which we are, you know, we're now living with the effects of that. But what I can see that one of the things we perhaps haven't done very well, and something we're now beginning to better, is looking at the system effects. So we're beginning to understand a lot better about managing our earthworks, and certainly one of the big strides that Earthworks team have taken is looking at predictive modeling. So they understand in a lot of places the composition of the embankments, and therefore they can do some modeling, to do some cycling based on different weather patterns to see what degradation is beginning to happen. Where they see that happening on some of the earthworks, they can put some instrumentation out there and start monitoring those. When we start looking at the renewal and some of the work with investment we need for the future, one of the things we want to be better at is look at the whole life cost of that system. So rather than just renewing the track and then thinking, well, it's new track, that's fine, but it's not an old embankment which carries on shrinking and causing poor top. That's not really an effective way of renewing our infrastructure. We need to look at the whole life element of it and the whole system effect. And I do think that's something we started developing a lot more, and there's a huge amount of collaboration on the parts of South East and Wessex between the Earthworks team and the track team, to look at ways of, you know, whether it's vegetation management, strengthening of particular areas where maintenance cost is actually quite high because of the amount of movement of embankments, and they're actually focusing on those locations and managing those and targeting those areas. So it's something that we need to do, but you know, I don't think we can move away from the fact that we'd need billions and billions of pounds to actually strengthen our earthworks. We won't. we will not do it in our lifetime. Probably a lot of people on this phone's lifetime, but it's something we've got to start. We have to start targeting the right areas, and if we do that, we'll get to a position where we've got that strength and built in.
Yeah. Okay. Yeah. Brilliant.
Okay, no problem, Chris.
So I think we've still got a few more minutes, so if it's okay to take a few more questions.
Yeah, certainly.
Robert. So Paul Morris has a question that he's going to ask.
Hi, Paul. No, I can't hear you, Paul.
Hi there, you can hear me, right?
Oh, I can hear you now, thank you.
Excellent presentation, Robert. Thank you, very much enjoyed that.
No problem.
Speaking about replacing things within my lifetime, I'm quite ambitious. I work with Unipart Rail and hopefully keen to do at least some bits and pieces.
Yes.
My query was, I wholeheartedly support the life cycle, the value proposition. Everything has to be done in accordance with low emissions and for the right reasons. But also, as you're predicting 50 years into the future, right? Obviously there are models, and then there are variables. New technologies will come. Look at what COVID's done to demand and travel patterns and use of technology. So I'm querying, how do you get your business case to invest billions for 50 years in the future without really understanding the return on investment or any variables that may come along and completely shift our demands as customers or freight?
Yeah, so no, that's a good point, and I think one of the things we're trying to do, Paul, is looking at. I mentioned earlier in the presentation about looking at the economic impact, because we don't look at that. We tend to look at the investment based on what the infrastructure is, but really the key thing is looking at the investment in the UK economy. So shifting people from A to B, and the impact that has based on the weather, and the more frequent that is. Something we learned from, if we look at people behavior and passenger behavior, the more the railway gets affected and gets disrupted, they turn away from that. So we know it's going to happen. We know it can happen. We saw that on some parts of the southeast during the Thameslink remodeling. Lots of disruption. People just left. People just moved away from the railway and moved elsewhere. And so it's a real thing, and we don't really measure what the impact of that is, the economic effect. So really, one of the things we're trying to do is to build models, not just based on the weather effect, but looking at economic models as well. If we can provide that, we've got our policies, and the policies define what we need to focus on. But actually, from the region's point of view, where the region's now devolved, can actually start looking at where they need to spend their money and where they need to invest, and they can provide a really good capital business and investment business case to look at the economic effect. So shutting off parts of the east and west coast, the southeast, and the coastlines where people want to go to when it's hot and sunny, and if we decide to shut our railway because it's too hot and sunny, that's not really going to watch very well with people using the railway. So it's something we need to develop far better, and we're working with government, and we're working with industries across UK, including the leisure industry as well, and the tourism industry, to try and gather all those costs, because I think that's where the real capital investment and justification for spending is key, and that's where it sits.
I like that answer, thank you. You're basically promoting it as an investment to keep the railways operational, rather than looking necessarily to get some value back. It secures the lifeblood of the country. It's an excellent answer, thank you.
Absolutely. You're welcome. You're welcome.
So I've just got two more questions here, Robert, in the chat. One is from Rufus. Is Rufus available to unmute himself to ask? If not, he's written it down.
Yeah, what's the range?
Are you there, Rufus?
Hi, Robert.
Hello.
Thanks for.
Hi, Rufus.
Thank you for your presentation, Mr. Ampomah.
Okay.
I just wanted to ask, what's the temperature range within the track bed usually? I mean,
not within the rails, just the track bed itself.
Yeah, the track bed itself.
Oh, that's a good question. I don't know exactly, actually. I think in effect the So we know that the effect of temperature will have, it's a combination. So rather than looking in isolation, it's a combination of effects. We know the poor water pressure on our embankments and our earthworks is certainly a factor, and that depends on how much water they're getting, but how much drought there is as well, and how much heat. So it's probably, yeah, there is certainly an effect on, as the embankments get warm. Clearly they, depending on where it is, what the lie of the land is of that infrastructure, it could actually contribute to the heat around the railway. So in 2018, over that 2-month period, 2.5-month period of continuous hot weather, we did see that the earthworks and the track bed was warming up over days, and we had temperatures which were very close to 60 degrees recorded in some places. Even though the temperature, didn't hit, we didn't get a record temperatures. We got 38.5. We didn't hit record temperatures till last year. But last year was very different because it was more like a really sharp spell, very short, sharp spell of hot weather, and then it disappeared. So we didn't have that long effect in terms of the track beds warming up. But it's a good question. It's something we do need to understand a lot better, because that whole warming effect accentuates the problem, not just for track, but it has an effect of the overhead line as well.
Oh, okay. All right.
Yeah.
Thank you very much.
Yeah, good question. Certainly something we should look at. Yeah. Thanks for that, Rufus.
So I believe we've got one question left, and this is going to be from Joss Apps.
Hello, Joss.
Hello, Robert. Good to see you. Long time.
Very long time.
Actually, I did see you down in London recently, but those days back at San Diego.
Oh, I know.
Good days. You obviously learned something and then moved on and worked it out. So my question is not about the lead length of a CDS turnout. You'll be glad to know. My question is to do about what can Network Rail do? What can Network Rail do better to protect themselves from third-party incursions? There's a lot of boundaries, and I'm not going to ask the obvious question, at the moment. But what can Network Rail do to protect itself from incursions from third-party land?
It's a very difficult challenge. So we've tried a number of times to get legislation in from government to support us. It's a difficult one, because some of the landowners, I guess, historically have owned that land before the railway came through. So yeah, there are some legalities which are difficult for us. But I think one of the things we need to do is actually embrace that. So we need to work with landowners, with third parties, even in local authorities. Some of the works that local authorities do with just purely with house building has an direct impact on some parts of our network, but we don't see it until we get the adverse weather or the extreme weather, and then we suddenly recognize how poor that is. So we've been doing some work with the Environment Agency, with local authorities, with water companies, both from a national level, but also from a regional level. And one of the things that government has helped us with, and I think government begins to push all infrastructure owners and local authorities, is each of them has to have a climate change plan and a strategy. And I think that's one of the things that everyone recognizes, all third parties included, that they've all got a part to play in this. So the impact that it has on a railway, when we go asking that question, is recognized because they are being challenged in the same way. Irrespective of that, I think certainly one of the things we're doing is we are using some, we're using some of the Environment Agency modelling in terms of floods prevention, and we need to do more of that. And what we're trying to encourage government, I think government is certainly keen on this, is building, a whole suite of different models with insufficient data. So when we look at BIM, looking at ways of extracting data from the Environment Agency and other sources to look at what effect it has on our infrastructure, and likewise they want to do the same as well. But that kind of information is not always readily available, and we need to work out ways across industry and cross different industries of sharing that information. A good example is power supplies. We work with with the power companies, but they have certain intelligence that we don't necessarily have access to. And if we've got awareness of those things, that's something we can do about where we recognize those weaknesses and build resilience into our assets. so we are less prone to any resultant failures from those systems. So that I think there's a lot to do, but I think government is definitely helping us as a whole industry, as a whole UK PLC.
Obviously, I think it's unfair that Network Rail gets used as a drain and is expected to get rid of any material that lands on its property. I think that's particularly harsh, especially given the amount of cuttings there are around.
Yes, yeah, but I agree, Joss, and I think one of the things we have to do, and we've shown it in really good examples in Cowley Bridge, is actually if we work together with local authorities, environment agencies, river authorities, we can find a solution together. Everyone chips in a little bit of money. We can all find a joint solution, which means we don't have, they might throw water at us, they might throw drains at us, but that's fine because we recognise it's coming. We can adapt to make sure we're ready for it. And we control the amount that's thrown at us. So yeah, I think there are ways of doing that rather than sort of sit as a victim. I think we can do things in a slightly different way and be more collaborative.
Good to hear, and good luck in your new role.
Thank you. Thanks very much, Jos. Is that all? Is that the last one, Liam?
Sorry, I was on mute.
I can't hear.
I think that was the final question.
Okay.
So Paul Richards is now going to propose a vote of thanks.
Thank you.
Hi, Robert. Many thanks for that. Excellent presentation. Very interesting. It brings back memories of when I worked on the FutureNet project, EPSRC FutureNet project with University of Birmingham. Back in must be 10 years ago now, and it's great to see that some of the outputs from that have gone into asset management policies going forward. So that's really good to see. Amused that you referenced the Daily Mail test. It's amazing how the press have got very ready to criticise the railway for not running trains, but it's very difficult to run trains when there's a lot of water on the line. We've lost the structure of the line. Yeah, as a Devon lad, of course, the Cowley Bridge area and Dawlish, very well known to me. And seeing the photographs of the huge working platform they've got down there, which is something a bit rather larger than your average railway infrastructure maintenance plant. So that's great. And yeah, so thanks very, very much for that. Another one, I mean, the soundbite that it's not really a soundbite. I think it's common sense. The phrase replacing like for better, rather than like for like. And that's a really good point. And I think that's something that the railway traditionally hasn't been so good at, is looking at what can we do better in terms of components and new products. Hopefully we can speed up the introduction of new products that can make performance of the railway better. So I'll stop talking. Thank you again, Robert, and I will just leave it to the audience to thank Robert in the usual way. If we can unmute everybody, please.
Thank you. Thank you very much. Thank you all very much.
Thank you.
Thank you. Thanks, Kate.
Thank you.